Hi, my name is Danica Cabrera from BI125 Section 4, and today I'll be dissecting a cow's eye. So first, we're going to take out the cow's eye from the perfect solution. Any parts of the specimen? Okay, so you can see here, you have the cow eye. So just put that to the side. Okay. So right now, what we're looking at is the adipose tissue, which is fat, and that surrounds the eye before we can get to the fibrous layer. This is what keeps the eye in the bony socket of the cranium. Now we're going to cut through the adipose tissue so we can get to the fibrous layer. Okay, some of the adipose tissue, you can already see some of the extrinsic eye muscles. These are the ones in the dark brown. And then these are the ones that are responsible for eye movement, up, down, medial, lateral eye movement. And as you can see here in the back of the eyeball, this is the optic nerve, and this is responsible for the primary sense of vision. Here, as we take out most of the adipose tissue, you can see more vividly the extrinsic eye muscles. The only problem with my eye right now is that it's not in the perfect shape and it was kind of smushed. So we're trying to carefully take out all the tissue without harming the fibrous layer. To make the longitudinal cut, I realized that I still have more fibrous layer, as I can feel the sclera right here. So I'm just going to cut through what is left of the adipose tissue. So now that we've cut all the adipose tissue, or as much as we could anyways, we have finally reached the fibrous layer. So as you can see, posterior to the eyeball is the sclera, and this helps maintain the eyeball shape. And then in the front is our cornea, which will help with light bending. Now we're finally going to make our cut, and it took us a while because our eye wasn't in the perfect shape, which is much expected. And we're going to finally make an incision right here so that we can view the inside. So right here, as you can see, we have reached the inside of the eye, and this will be considered the vascular layer of the eye. As you can see here, we can see the vitreous humor, which is a jelly-like substance, and this is a part of the posterior eye segment. So we're just going to scrape that out. We now see here this brownish layer is our retina, and our retina, in there, its neural layer actually holds all the photoreceptors, bipolar cells, and the ganglion cells. And so the photoreceptors include rods, which allow us to see dim color, and the cones, which allow us to see visual acuity, so all the colors basically. And then just posterior to the retina, as we're gonna do softly, this dark layer is our choroid, and this is responsible for nourishing the eyeball, and it also absorbs excess light that enters in the eye. This colorful layer right here, a part of the choroid, is the tapetum lucidum, and this is only found in animals, which allows them to see at night or in the dark. Humans do not have this. We have the lens. We can just gently remove the lens. Okay, we have the lens. This is responsible for refracting light into the eye. You can see there's fluid here, and this is the aqueous humor, and this is a part of the anterior segment of the eye. So we're just gonna move this. Now that we've taken out the lens of the anterior side of the eye and the aqueous humor, we can see striations inside here, and these are actually the ciliary bodies and muscles which manipulate the shape of the lens, how much we see through farsightedness, nearsight, or accommodation. And the ciliary processes of the ciliary body actually create the aqueous humor that we just saw earlier. And just medial to all of the ciliary bodies, we have the pupil here, and this actually allows the light to enter into the eye, and around that we have the iris, which controls the amount of light that enters the eye through relaxation or constriction. We have the eye here, and then we have a light on this side right here. So in a live specimen, the light would actually hit the cornea through the pupil, and depending on the amount of light that's being let in is based on our iris. Then it will go through and hit our photoreceptors, bipolar cells, and our ganglion cells, and ultimately be sent to our optic nerve here that will allow us to see the images that we do in our everyday life. So thank you again so much for seeing my video.